Hello everyone, this is Dr. Marrero from Math Topics. This video is my personal approach and my personal recommendation on how can we introduce quadratic equations or quadratic functions to our math students. This can be done in Algebra 1 or in previous advanced courses in middle school. But I think that the way we engage the students into this extraordinary world that is quadratics must be relating quadratics with reality and not the simple abstraction of ax to the second power plus bx plus c equals 0. That way, number one, the students won't learn lifetime. Second, they are going to forget what they are learning. So it's important to introduce quadratics in the way that historically was found, with some elements from history, from some elements from science, that they are able to see and make sense of the topic. Let's start exploring quadratics, my personal tips. To introduce quadratics, I think that we should start with geometry. This is the number one tip, my number one recommendations. We have to start with geometry. Let's see, how can we start with geometry? I recommend to start with square. Why the square? Because we are going to integrate in our topic, in our quadratics topic, geometry and algebra. But the beginning of all of this, historically speaking, is just geometry. So we have the square, and we know that all the sides are the same. So all the sides are equal and unknown value that we are going to label x. Let's see how geometry make the transition to algebra. Let's explore the square. It's super important to explore the square. So I have here the square. Remember that all the sides are the same. So we can, let's say, label the size of the square. So because it's a general square, we can use x, okay, for each side. So let's start doing this. So I'm going to label the square. Going to use x. All the sides are the same. And now the fundamental idea of how much is the area of the square. So let's say that the area of the square is x times x, or length times width, so that you can express this as x to the second power. So this is x to the second power. And this is when the teacher immediately have to make the connection with algebra. We are using variables, and immediately after we are using a structure here that is called equation. The area is equal x times x, or a equal x squared. And this is when the teachers needs to make the opening of algebra, the opening of a quadratic structure. So x squared is no more than the area of a square with sides x. And that expression, x squared, is a quadratic expression, is a quadratic structure. Because the student needs to know that the beginning of all of this was how to find the area of that square with side x. And the mathematician in the past, they came up with the idea of length times width. They create that expression x to the second power, but that x to the second power is a geometrical idea. that later on is made the transition to algebra. So a quadratic expression or a quadratic structure is no more than the area of the square with side x. This is important to put emphasis on that, and really important to introduce quadratics. The geometrical view of the expression x to the power of 2. You have the equation, you have the quadratic equation there. Because if you say here that the area of this square is 64, you know that the x is the square root of 64, which is 8. So this particular individual square, the x is 8. So, and immediately the teacher needs to explore that the 8 times 8 is 64, but also you can have one student that said, what about negative 8 times negative 8? And this is when the negative comes. But in the beginning of if we follow the history of mathematics, the negative didn't exist when they create this idea of the area. So that's not make sense. Now we have an area of negative 64 square feet or negative 64 square meters. So we are not using the negative value, but it's important for the students right now to understand that yes, we have two solutions, but in geometry terms, we are going to use only the positive because we don't have that negative. And look at how many things are going on and playing here. Now we're working with geometry, with a simple square. We're working with the size of the square. We are finding the area. We are creating the algebra expression a equals x to the second power. We are finding actually one particular side of that square that in this particular example is 8. But at the same time, we are working with a square root and we are working with two different solutions. And now is when the teacher is not saying that we are going to have at most two solutions in the future with quadratics, but the students will connect. When they see the possible solutions in a quadratic equation, they know, because they know that this is coming from the geometry perspective, that we're going to have two solutions. And sometimes in geometry, we are not going to use the negative solution. So in only one shot, you're working with too many ideas and too many concepts. Let's see what is next. I want the teachers to know this, and this is my second tip, my second recommendation, that you show the students geometry, the images of the geometry elements, and the structures associated with those geometrical elements. This is important when you are introducing algebra topics, in this case, quadratics. So how can we do this? Very simple. So I'm going to use a line right here, a line segment, just a line segment. I'm going to use the square. Okay, let me put the square right here. And I will use a cube. So I'm going to use the cube right here. And we have the three elements right now. So we have the segment, we have the square, and we have the cube. What we do with this? Very simple. The length of that segment is x. The size of that squares are x, x, and x, and the area that we just discussed is just x to the power of 2. So we are working with length. We are working with length and another measurement, the area, which is x times x squared, quadratic. And then we have a cube here, very nice, with all the sides, length, width, and height the same. And we can use another measurement, so the volume, the capacity, which is no more than x times x times x, which is no more than x to the power of 3. Now we have the length, we have the area, we have the volume. We have linear structure in algebra, we have a quadratic structure, and we have the cubic structure. This is my second tip, my second recommendation. And when the students are learning this way, they are learning mathematics. And they are learning what is important, lifetime mathematics. Let's see what is the next tip. The last tip, the last recommendation when introducing quadratics is history. We have to go over the history of science. And this is something that will motivate and will engage the students. And remember, what is the purpose of this video? To show you some tips that I have used when I'm teaching this topic to students. History is the origin of the subject that we are trying to teach and the students are trying to learn. History. We have to talk about Galileo and the achievements and the formula created by Galileo. Let's see how that works. Let's go over the discovery by Galileo. So let me magnify here one of my notes, and you can see here the parabola, which is the quadratic representation, the description, the geometrical description of the motion of on Earth. We have a particular example that I will be going over later. It's the vertical motion of a ball. But let's go over Galileo achievements. Important, the discovery of the law of falling bodies. Galileo discovered that the distance an object falls is proportional to the square of the time it has been falling. This relationship is a quadratic function. Mathematically, it can be expressed as d equals 1/2 g times t squared, where d is the distance, g is the acceleration due to gravity, and t is the time. If you want to know more about this formula, so I invite you to go to my channel and find the Galileo equation video. It's more or less about the history of this extraordinary equation. But the idea of the video today is to show you when quadratic expressions came to play in the history of science and in the history of mathematics. And immediately I want you to check the structure, the t to the second power, that makes that equation a quadratic equation. So let's see one example that I want to discuss with you. So right here, one mathematical or physical problem based on the initial velocity of 20 meters per second and using the acceleration due to gravity as 9.8 meters per second squared. The answer to the questions, to the 4 questions are, what are the 4 questions? Give us an equation describing the height of the ball, the maximum height reached by the ball, typical and classic quadratic question, time to reach the maximum height, and total time the ball is in the air. So using that formula, using that equation, we can answer all the 4 questions. So the equation describing the height of the ball is a quadratic expression, a quadratic equations. How can we find the maximum height? Okay, finding the maximum height is no more than finding the x of the vertex in a parabola. Time to reach the maximum height. What is the time that the parabola or the ball needs to go all the way to the maximum, all the way to the vertex? And the total time the ball is in the air. So the zeros of the equations, the zero of the function, because it start right here at 0, 0, it start moving up, reach the maximum height, and it start going down and hit the ground. So that interval of time can be found using factorization, using the quadratic equation formula, or using the roots of the polynomial. But this is another topic. The idea is, how can we be successful introducing quadratics? And the tips are clear. We have to use history. This is important. The origin, the reality of the events, and how we, the humans, explore the physical world, and how can we create structures to explain the events of the real world. I hope this video allow you to explore more about quadratics and enrich more your experience as a teacher, if you are a new teacher. So this is elements that I have learned throughout my teaching life. Of course, quadratic is beautiful. I have more videos about the topic that I invite you to watch. And of course, if you've reached this part of the videos because you like it, so please share the video to support math topics. Don't forget that we have a website, marreromath.com, and also we have a monthly newsletter that, if you want, I'm going to leave the description below, and you can sign up to receive free the newsletter. And this is what I have for this week. How can we explore quadratics in a way that the students can learn lifetime? That's the purpose of math topics. Thank you so much. See you in the next video.